You're watching the Learning Channel.
For thousands of years, they've frightened and fascinated us. Astronomers have reached out to probe their mysteries. So what are these things which are the stuff of legend and awe? Comets, celestial visitors sometimes glimpsed, but once in a lifetime. Comets are the nomads of our solar system. Some travel on random elliptical orbits, hurtling among the planets. Kamikaze comets plunge directly into the sun. Others just graze its fiery surface, never to return. The story of comets is old. To understand where they come from and why they're important, we have to journey back nearly 5 billion years to the birth of our solar system. In a primeval nebula, the heavier elements coalesced to form the sun and the inner planets, solid little worlds like Earth and Mars. As the sun grew hotter, it generated a solar wind. Upon it were carried lighter elements. They would form the outer planets, gas giants like Jupiter and Neptune. Beyond them, a third of the way to the nearest star, the solar wind deposited a shell of dust and ice known as the Oort cloud. It's from Oort that comets fall. Perhaps nudged by a neighboring star from the equilibrium of Oort, a comet will tumble relentlessly toward the sun. The nucleus of a comet is a clump of dirty ice. It can range in size from a football stadium to an entire city. Unaltered by time or temperature, the core is a relic of our solar system as it was, in the beginning. Nearing the sun, the ice begins to vaporize, streaming a fluorescent tail of gas. As it passes, the tail is blown backward by the solar wind. Thus begins the multi-billion-mile odyssey of a comet.
Wonders of the Universe will continue on TLC. Wonders of the Universe continues on TLC.
A comet's tail can stretch 100 million miles across space. But it only exists within the warmth of the inner planets. As the comet returns to the cold outer depths, the tail will disappear. From Earth, comets can grace the heavens for weeks at a time. This is Comet Ikeya Seki, seen in 1965. And this, Comet West, in 1976. Though traveling at many miles per second, they appeared to hang motionless in the sky. Beautiful and serene, comets can seem far removed from our everyday lives. Yet, in the ancient past, comets collided with Earth and may do so again. In 1994, the target was Jupiter. But the sun is the most common target. Here, in time-lapse, one just grazes the surface. And here, comets plunge into the solar furnace. In the wake of comets come shooting stars. Comets are cosmic litter bugs that leave dusty trails behind them. Hitting our atmosphere at up to 40 miles a second, the dust burns up through friction. Even tiny grains can spark the night as meteors. Larger pieces of debris from space produce spectacular fireballs. If they're big enough, they'll survive to hit the surface of Earth as meteorites. Just by chance, a man with a video camera caught this fireball breaking up over Pittsburgh in 1992. Perhaps the most famous rock from heaven is set in silver at the base of a black structure known as the Kaaba. In the holy city of Mecca, it's the time of the Hajj, when millions assemble at this birthplace of Muhammad. Like Muslims throughout the world, the pilgrims pray toward their sacred stone, believed to be a gift to Abraham from the archangel Gabriel. But there's a more down-to-earth view of it. Some scientists suggest the stone may be a meteorite, one of the countless missiles that have pocked Earth's surface since our planet was born.
Wonders of the Universe will continue on TLC. Wonders of the Universe continues on TLC.
Mount Palomar, California, and through this telescope, an astonishing discovery. In 1993, three astronomers, Eugene and Carolyn Shoemaker and David Levy, had found a strange new comet.
This comet was discovered by us and by a young Frenchman, Philippe Benjoya, from Nice, France.
At Kitt Peak, Arizona, where the Spacewatch telescope hunts for celestial intruders, the Shoemaker-Levy observation was confirmed. This was no ordinary comet. Dubbed Shoemaker-Levy 9, it was a streak of light in orbit around Jupiter. A comet with multiple hearts. Worldwide, astronomers were ready. In the Chilean Andes, at the European Southern Observatory, trackers eagerly recorded images of the new comet. What they saw was not a single comet, but a whole squadron of comets flying in formation, each with a dusty tail. Pictures from the Hubble Space Telescope revealed a string of pearls. They were formed in 1992 when the comet strayed too close to Jupiter. Its immense gravitational forces had torn the comet apart. In 1994, these mountains of debris would return to slam directly into Jupiter at 130,000 miles per hour. Scientists and artists alike conjured visions of what might happen. For the first time in recorded history, we would watch as a comet collided with another planet, the giant gas ball of Jupiter, 1,300 times bigger than Earth. July 1994, and in New South Wales, the Anglo-Australian telescope was zeroing in. The week of the comet was at hand, and Shoemaker-Levy was performing brilliantly, far better than astronomers had dared hope. Day after day, as the string of cometary fragments hit Jupiter, their points of impact came into view. Heat-sensitive images recorded over 20 major collisions. Some were bigger than expected. In Australia, astronomers awaited a grand finale.
Okay. Okay, Sunday. Okay.
Oh, God. It's going to be bright.
An astronomer's dream, front row seats for the first celestial impacts ever predicted.
And then you'll see at the bottom of the image, if one of them will get particularly bright, so down at the bottom, very edge.
The impacts had come thick and fast. Each comet fragment had a letter. Tonight's vigil was for Fragment W. David Crisp of California's Jet Propulsion Laboratory was team leader. As W approached Jupiter, tension mounted. Would the comet end with a bang or a whimper?
Yes, that's right.
It was a dazzler, a signal so bright the astronomers had to protect the telescope's delicate sensors.
Close down just a touch, Frank. Down to 2.3 probably.
60.
And now for the picture of the blast.
Wow!
Whoa, got it! Very dramatic.
That evening, Crisp's team had captured the best image taken on Earth. Halfway across the world, in the U.S., the comet's co-discoverers were the toast of astronomy, household names.
I think we're very, very privileged tonight to see an event that's not once in a lifetime. It's once in a millennium.
Nature calls you on the phone and says, I'm going to drop 20 comets into Jupiter at 138 miles an hour. All I want you to do is watch.
It's a champagne experience.
The Shoemaker-Levy string of pearls a month before impact. In the ring, Fragment W. The accuracy of astronomers in predicting the impacts had been breathtaking. In heat-sensitive infrared, the impact sites shone like cat's eyes. But there were few pictures like this sequence taken from the Galileo spacecraft. Here, Fragment W hits the dark side of Jupiter. In Hawaii, the mighty Keck telescope imaged a blast as it came into view from the Earth. A mushroom cloud 600 miles high rose above Jupiter's horizon. From its perch in Earth orbit, the Hubble Space Telescope had made round-the-clock recordings. Hubble took this brilliant portrait of the Shoemaker-Levy fragments hurtling towards Jupiter. And Hubble snapped this mugshot, the battered face of Jupiter with half a dozen black eyes. On Earth, such collisions would have been catastrophic. The dark crescent in this picture is a shock wave as large as the Earth itself. The path of Comet Shoemaker-Levy had been predictable. There's also another comet known for its predictability. And our youngest viewers may well see it on its next return.
Wonders of the Universe will continue on TLC. Wonders of the Universe continues on TLC.
Long ago, another comet swung close by Jupiter. It too, like Shoemaker-Levy, had its orbit forever changed by the gravity of the giant planet. That comet was Halley. Today, it travels on a long elliptical orbit that carries it out beyond Neptune and back again for a spin around the sun. Thanks to Jupiter, Halley is locked into a 76-year cycle. It last came our way in 1986. It's due back in 2061. Our understanding of comets began with Halley. More than any other, it's helped unlock the mystery of their origin. The story begins with the 17th century astronomer Edmund Halley. Until Halley's time, scientists thought that comets were only one-time visitors to our skies. They simply careened past Earth, never to return. But in 1680, Halley's friend, Isaac Newton, carefully observed the motion of a comet. He worked out that it was traveling in a closed orbit around the sun. The deduction was part of his theory of gravity. Newton suggested that a comet with a small enough orbit might be seen again and again. To test the idea, Edmund Halley analyzed the sightings of 24 comets. Two important observations emerged. First, 3 of the sightings were separated by the same 76-year interval. Second, these same 3 comets seem to have virtually identical orbits. Could they be one and the same comet, a regular visitor? If so, the next return should be in 1758. Sure enough, on Christmas Day, 1758, long after Halley's death, the comet reappeared. They named it Halley's Comet. The revelation allowed astronomers to trace the comet back through time. One of these Chinese tomb drawings confirms Halley's appearance in the 2nd century BC. A coin struck in memory of Julius Caesar also bears an image of Halley. It had been seen in the emperor's youth. This, from 648, is what people called a broom star. It's the same comet. In 1301, the Italian painter Giotto made Halley's comet the Star of Bethlehem. Halley wasn't seen that first Christmas, but some astronomers have suggested another comet led the wise men on their journey. By Halley's appearance in 1910, the world of advertising had caught up with history's most famous comet. Scientists greeted the return of Halley with a new tool, photography. But the pictures lacked detail. The comet still withheld its secrets. Three-quarters of a century later, in 1985, Halley's comet was back. This time, super-sensitive cameras, giant telescopes, and a fleet of probes lay in wait. It was Halley's space-age debut, with pictures galore. Here, a head-on shot with spirals of comet gas trailing into space. By 1986, the best images were from the southern hemisphere. These, from Chile, after Halley had rounded the sun. And this from the unpolluted skies of equatorial Africa, a fuzzy cloud called the coma, clearly visible as it shrouded the comet's nucleus. Curved tails of dust that appeared yellowish to the naked eye. And a straight tail of gas fluorescing blue over millions of miles. Another view from Africa. For the first time, scientists did more than merely observe the comet. They reached out to it. As Halley sped past, an armada of robot spacecraft raced to intercept it. 2 Soviet, 2 Japanese, and a European probe named Giotto. Giotto was going for the closest of close encounters. Scientists planned to fly Giotto directly through the inner coma of Halley's comet and record it on video. As Giotto homed in on its prey, computers purposely painted the comet in false colors. These allowed scientists unprecedented insight into the comet's brightness and density. But the pictures disappointed television viewers. "18 months later, supercomputers finally produced the view the public had expected, and few have seen until now. At the center, a peanut-shaped nucleus, a lump of primeval matter 6 miles by 9. Geysers of gas streamed at 20 tons a second, dust at 10. Through the fog, this was the very face of Halley. The video transmission was knocked out with fewer than 1,000 miles to go, but Giotto had unveiled a hard, darkened shell with an icy interior. From Earth, Halley put on its best show as it pulled away from the sun. Photographed over several months, the comet's tail lengthened and shortened day to day. Its overall brilliance fluctuated too. Astronomers attributed the variations to the solar wind, to changes in the composition of its surface, and to the rotation of the nucleus. From the deep chill beyond Neptune to its tour of the sun, Halley's surface had heated to over 200 degrees Fahrenheit. In the late 80s, as Halley receded, so its image faded. Then suddenly, in 1991, it brightened. Could the comet have collided with something? We'll find out in 2061. By February of 1994, Halley's comet was just a few specks on a photograph as it headed out past Saturn. The future will bring new comets. American and European astronomers propose actually landing on a comet. The craft will carry no astronauts. They would never survive. Instead, a powerful robot dart packed with sensors will do the job. Like a doctor's probe, the dart will take the first direct readings of a comet's temperature and chemistry. Then, via the mother craft, beam the data home. Comets, icy visitors from the depths of space. We have gazed at them in wonder, flown through their gossamer folds. Someday, we may actually touch these messengers from beyond the planets.